Hi students, my name is Samik Khan. Today I am teach you the subgroup. Already in my class, already I am discussed what is the group. Group means we must be satisfy the four properties: closure property, associative property, identity property, and inverse of a element. Now today I teach you what is subgroup. Subgroup means a non-empty subset of H of a group of G comma compose is said to be a subgroup of G if H itself a group. G is a set and it is a group, means four properties are satisfied. Okay, and H is a non-empty subset of this group. Non-empty subset of this group. Then if it is also a group, means satisfy the properties, then it is called the subgroup of these sets. ঠিক আছে, every set you know from the set theory that every set is a subset of itself. No, so every group is a subgroup of itself, and every group G comma compose has at least two subgroup. Clear? At least two subgroups. Now the two examples are given here. The multiplicative group of this is a subgroup of a multiplicative group of this, and the additive group of integer is a subgroup of a additive group of integer. These two are the example. And another thing you must be remember, the identity element of a subgroup is the same as that of the group. Identity element, if you form, if G comma compose is a group, there is a 5 subgroups, and each and every subgroup must be the same identity element. Clear? So that's why the identity elements of each subgroup is same of the group. Now one of the important theorem is there: a non-empty subset H of a group of G comma compose is a subgroup of G if and only if these two properties are satisfied. These two we have to prove: necessary and the sufficient condition. The necessary condition means ki means হচ্ছে কি G comma compose is a group. Now you have to prove these two. So H is a subgroup of G comma compose. We are written here H is a subgroup of this. What we have to write down in a statement, that 8 must be a group. তাহলে H itself a group means it is satisfy the closure property. Closure property means you know कि two elements A B belongs to G, then A compose B belongs to G. So first property is satisfied using the closure property, and you know the inverse of a element also satisfied. So if A belongs to G, then the inverse of the elements also lies. So the second property is also satisfied. Second statement is also proof using the properties of the closure and the inverse. Now the we have to prove the condition is sufficient, means these two statement is true. Using that we have to prove H is a subgroup. Subgroup means ki you have to prove that this is a group. Clear? So group means the four properties must be satisfied. You see from the first these two condition are given, so means ki AB belongs to G, A compose B belongs to H, so means closure property satisfied. Clear? And the operation is associative in H if it is holds in G. G is already a group, so it is holds in also G, so the closure property satisfied, associative is satisfied. Now from the third statement, from the second, you know A belongs to G, A inverse belongs to G. You write down here A belongs to G, A inverse belongs to G. So closure property already satisfied here. তাহলে A compose A inverse belongs to G, because using the one closure property. তাহলে A compose A inverse means কি E. তাহলে identity elements also satisfy. So the three properties also satisfy. Now you have to prove the last one, the inverse of a element. So from the second, each of the elements in G, so H is a group. So what we have to see here, A belongs to G, A inverse belongs to G. If these two statements are correct, then using that you have to prove H is a subgroup. Okay, so four properties are satisfied here: closure property, associative property, identity property, and inverse of a element. Clear? Now go to the second theorem, the necessary and sufficient condition that a non-empty subset H of a this, we have to prove this. Again the necessary condition is necessary means this statement is true, using that you have to prove this. তাহলে H is a subgroup of this. তাহলে already I told H is a subgroup means কি H itself a group. তাহলে H itself a group means কি it is satisfy the four properties: closure, associative, identity, every properties, and inverse property. If B belongs to G, তাহলে if it is a group, so inverse is also belongs to. Now take another element, A belongs to G and B এর inverse belongs to G, so closure property must be satisfied because it is a group. তাহলে using these two, A compose B এর inverse is belongs to G, তাহলে H is a closure. তাহলে both of these things, this is proof, A compose B belongs to H. Now the condition is sufficient. Sufficient means ki this is true, using that we have to prove H is a group. So four properties must be satisfied. তাহলে we have to take here AB belongs to H, this is given. তাহলে we have to take two element A comma A, same element. তাহলে A compose A এর inverse using this. তাহলে A compose মানে E, তাহলে identity property satisfied. E and A belongs to H, A belongs to H and E belongs to H. তাহলে E compose A এর inverse belongs to H using this. ঠিক, তাহলে E compose A এর inverse means কি A এর inverse. ঠিক, তাহলে A এর inverse is also belongs, তাহলে I inverse property satisfied. Then we go to AB belongs to H, B belongs to H, then B এর inverse belongs to H, already proved the inverse property. তাহলে A comma B এর inverse belongs to H. If you compare with this, AB belongs to H, A compose B এর inverse belongs to H. তাহলে A compose B এর inverse belongs to, তাহলে A compose B belongs to H, closure property satisfy, closure, inverse, identity, and associative is it holds in G, so it is a group. Clear? Now we go to the second lecture for the next theorem.